Alright, this is a brief rundown of the law of cosines. We normally in the past have derived it, proved it in class, but for time's sake we're going to kind of speed through this process a little bit. First of all, I'm going to jot down something that should look familiar to you. And hopefully you recognize that to be Pythagorean's theorem. So I'm going to show you a quick little change. Remember, Pythagorean's theorem are for right triangles, and law of cosines is for triangles that traditionally don't have a right angle in them. And it's going to start very similar. So hopefully you notice so far all I've done is rearrange this. I wrote the c squared first and a squared plus b squared there second, and then the adjustment for the fact that it is not a 90-degree angle. And that's the extra part. That's the part that's going to cause you some troubles. All the lowercase letters that I've used in the formula represent the sides of the triangles. So this C and this A and B that you see here are three sides, and this is supposed to be a capital C, meaning one angle. So when we use law of cosines, there's four pieces of information in the formula, and we need to know three of them in order to use it, which means our unknown is going to be placed in the formula somewhere, and the place for your unknown will either be in this first location, if you are trying to find the side or a missing side of the triangle, or your unknown will go here in the angle location. So the little a and the little b that I have here twice in the formula, you have to know. You won't put an unknown in those two locations. So the traditional triangles that we use for law of cosines will be a triangle where you're given two sides. I'm just making up one right now, bear with me, and the angle that's in between them. So a lot of times we'll refer to this as a triangle in the form of side angle side, or a triangle where you're given all three sides. So these are your traditional two triangles that you'll start with where law of cosines will use. And that's mainly because law of sines doesn't work. If you try to do a law of sines proportion right now, you'd have two unknowns and you wouldn't be able to do it. So law of cosines will be used in this class for these two triangles. So let's go to problem number 1 of your worksheet and try to figure out the missing information using law of cosines. So this says solve the triangle, so that means find all three pieces of information that are missing. And the first one I'm going to find is the side opposite capital C, this side over here, which the ditto here will refer to as side AB. I'm going to refer to it as little c. So since that's the side that I'm trying to find, that goes first in my formula, c squared. A and B represent the two legs that are given to you. These two legs here will be placed in the formula, and they don't matter how they're placed. I could have wrote the 28.9 squared first. I wrote the 8, and that's okay. Both of these are interchangeable. Now when your formula is all written out, it is important to know that the side that we're solving for and the angle that we have, these two pieces of information right here, are always opposite one another. So whatever side is placed here, this has to be the angle opposite that side. Alright, in this one you'll notice that our unknown is out here by itself. So we've got a long list here of mathematical operations that our calculator is capable of handling all at once. So I'm going to head to my calculator and type everything that you see right here without actually having to hit enter or clear. And there it is. That's the answer to this entire list. Of course, keep in mind that that number is still equal to c squared. So we've got one small step to finish this problem. And while I'm here, it's good to talk about this. don't ever use a rounded answer in the process of solving or with more mathematical operations still to go. It'll just compound the error that you're having. So when I go to square root this, I'm going to square root this previous answer, so I have no round off error until I go to write my solution on my paper. So I'm going to square root the previous answer, and that's that missing side. 26, and this ditto again says round to the nearest tenths, so it looks like we're going to 26.6 for little c. Now the ditto did say to solve the triangle, so we've got to find the other two missing angles. Now I can use law of cosines all over again, totally fine to do, since I have enough information to do it. However, traditionally law of cosines only needs to be done once, and at that point law of sines becomes available to us, and that's what I'm going to do because it does take less space, and for a lot of people it's more familiar and friendlier to them. So I'm going to start with a law of sines formula of 65.5 and put it over the side that's opposite it, and that's the side that we just found. That's the 26.6. Now we got to be careful here. This is a rounded answer, and for this ditto, I believe a lot of the answers on this worksheet, they use rounded answers to solve the rest of the problem. So you might be off by a tenth or a hundredth at some point, and that's because this program does it. Hopefully, we're going to store exact answers so that we don't have any round off error in these problems. Now I have to go pick an angle over here. I could choose B in the 8, or I can choose A in the 28.9. So I'm just going to grab angle B. That's what I don't know, and that's what I'm going to try to solve for. The side opposite that angle is the 8. So I've got a law of sines formula using the new side that I found earlier from law of cosines. So traditionally, and we should get used to this, especially if we have a large calculator, this is the actual answer for that side that was missing. I'm going to store it using store, which is the button right above the on button, so that I have that exact answer at my disposal. I hit X to place it in for the letter X. So now whenever I hit my X button, I've got that decimal in its entirety, not rounded and have any error. And I'm going to use that instead of 26.6. So let's head back to law of sines now and cross multiply this. I have 8 times sine of 65.5 is equal to 26.6 times sine of B. And then I'm going to have to divide both sides by 26.6. Now I'm writing 26.6, but I'm not actually going to use that number. So I'm going to head to my calculator here, and that'll get sine B by itself. We'll have one extra step after that. So 8 times sine of 65.5. I like to hit equals after I do the numerator. And then I'm going to hit divided by, and instead of 26.6, I'm going to hit divide by X. So I've got this weird decimal. Remember, that decimal is still equal to sine of B. So at this point, I need to get rid of the word sine, and canceling would be inverse sine. And if I use the previous answer button, again, I don't have any round off error. So inverse sine of the previous answer will give me that missing angle, 15.88. Since this is a round to the nearest tenth ditto, looks like we're doing 15.9. So angle B is 15.9 degrees. Alright, last angle to find. Since I have two angles of the triangle, the third one should be a piece of cake. We're not going to use law of sines. We're not going to use law of cosines. We're just going to simply subtract those two angles from 180. And looks like 98.6. Angle A, 98.6. Okay, since that video was kind of long, I'm going to do another video and do a side problem number 3.